So hi, good day everyone. So this would serve as your pre-recorded discussion about lesson 3. So we've already discussed lesson 1 and 2, which is lesson 1 for the introduction to general chemistry and its branches, and for lesson 2 for the classification of matter, or the classification and properties of matter. So for lesson 2 I already discussed also, or I also give you a hint about our topic today. So I already give you a summarization about how matter can be classified, or how matter can be separated. So as we all know, matter can be separated physically by the means of mixtures and substance. So today, let's start our discussion by defining what is substance. So substance is a form of matter that has a definite constant composition and distinct properties. When we say definite constant composition and distinct properties, meaning to say any kind of matter that has a uniformity by the uniformity in its property. So that is substance. So example of it, we have water, carbon dioxide, ammonia, methane, glucose, gold, oxygen gas. So again, when we say substance, it is any kind of matter that has a uniformity with regards to its properties. So next to that, we also have mixtures. Mixtures is a combination of two or more substances in which the substance retain their distinct identities. Mixtures are either homogeneous or heterogeneous. So meaning to say, when we say mixtures, it is a combination of one substance to another substance. When you combine a substance to another substance, that would leads to mixtures. And one of the example of mixtures are smoke and fag. When you combine smoke and fag, that is an example of mixtures. When you combine smoke and fag, as you can see, the identities or the distinct identities of the smoke and fag will retain, right? Even though you combine it. So if you combine smoke and fag, you can create a smog, and by that the identities of two substances is will retain or will be the same. Aside from smoke and fag, we also have dirt and water, which leads with mud. If you combine dirt and water, but the physical appearance of dirt and water, there is no changes, right? Even though you mix it. So that's why it's said that when we say mixture, it is a substance, or it is the combination of two or more substances in which substance retain their distinct identities. So meaning there is no changes at all. So it will retain by its physical appearance. So what else? We also have water and salt. From the mixing and the combination of water and salt, as you can see, wala ring nangyayari with regards to physical properties of it. Or the both substances will retain to its distinct, or to its original appearance, to its original, to its original properties. So yun na nga sinasabi natin na when we say mixture, kahit nag-combine yung dalawang substance, makikita mo pa rin, or remain pa rin yung properties, or it will walang changes, it will retain their distinct identities. So that is mixtures. So next to mixtures, as I've said, mixtures can either be homo and heterogeneous. So let's discuss first what is homogeneous mixture. Homogeneous mixture is actually a mixture once well mixed, the composition of the mixture is the same throughout. There are two groups that can be categorized under classification of homogeneous mixtures. There are solution and colloid. So further explanation for homogeneous mixtures is that when we say homogeneous mixture, it is a mixtures, to explain it furthermore, it is a mixtures in which the composition is uniform throughout the mixture. So meaning to say, homogeneous are mixtures in which constituent do not or don't appear separately. So what are those example of homogeneous? We have blood, sugar solution when the sugar is completely dissolved. As you can see, when you mix the sugar and the water, you cannot the other substance will be disappear, right? you cannot see eventually the two substance. Hindi mo makikita yung dalawang substance sa homogeneous mixtures kasi ang mare-retain lang with regards to its physical appearance is the water, kasi the sugar will be dissolving to the water once you mix it. So that's why it will retain with the appearance of it is only for the water, not for the salt. So that is one of the example homogeneous mixture. Aside from that, if you mix alcohol and water, that is actually one of the example of homogeneous mixture. If you mix the soap and water also, you can eventually know that it is homogeneous mixture. So meaning to say, the simplest definition of homogeneous mixtures is when the mixture is in is actually mixed as one. Mix as one, meaning to say yung hindi mo makikita yung other substance. When you mix the substance, eventually the other substance will dissolve to the other substance. So that is homogeneous. Kaya nga tinatawag na homo, meaning as one. So if you mix the substance to another substance, meaning to say the other substance will dissolve to the substance na na-mix mo. That's why it will leads to one. Kaya sinasabing homogeneous leads to one substance from the mixing of the both substances. Okay? So let's proceed now to the classification of homogeneous mixtures. We have solution and colloids. Let's discuss first what is solution. Solution is a homogeneous mixtures of two or more substances depending on its more obvious phase. Solution could be further categorized into solid, liquid, and gaseous solution. A special class of liquid solution in which water is the solvent is called aqueous solution. So to discuss it furthermore, solution is an homogeneous mixture of one or more solutes dissolved in a solvent. So meaning to say, there is two division in solution. We have solute and solvent. Solute, that is actually being solute is the substance that is being dissolved, while solvent is the dissolving medium. Meaning to say, for example, if you mix sugar and water, sugar is actually the solute. Why? Sugar is when you mix sugar to the water, sugar will be being dissolved. Madidissolve si sugar sa water, then yung water now ang iyong solvent. Bakit? Si water kasi yung nagiging dissolving medium ni sugar. So that's why when we say solute, it is the substance that is being dissolved, and when we say solvent, it is the dissolving medium. Okay? So much for that. Let's continue our discussion for colloids. Colloids are homogeneous mixture whose particle size that fall between 1 to 100 nanometers. It bridges the gap between solution and suspension. Colloidal particles may be dispersed in either liquid or gas or even media. Okay. So meaning to say, when we say colloid, it is a mixtures that actually one substance of microscopically dispersed insoluble particles are suspended throughout another substance. So colloid has its dispersed phase, which is called as the suspended particles, and also colloid has its continuous phase, which is called as a medium of suspension. So if solution has a solute and solvent, colloids also has a suspended particles and medium of suspension. So that is colloid. So what are those examples of colloids, particularly in a food? Okay, example for colloids in a food is that whipped cream, mayonnaise, milk, butter, gelatin, or jelly is an example of a colloid. So aside from colloid, we also have the so-called process, which is Tyndall Effect. Tyndall Effect is the scattering of light. As a light beam passes through colloid, the individual suspension particles scatter and reflect light, making the beam visible. The Tyndall Effect was first discovered or described in 18th century by physicists, namely John Tyndall. So Tyndall Effect has come from the name of the physicist who discovered it, which is namely John Tyndall. So to explain it further, what is the Tyndall effect, what is the process in Tyndall effect in the mixtures which is colloid, there is an illustration here. So this is the best way to explain the Tyndall effect. As you can see, when the light source passes throughout the solution, for example, colloid, example, and suspension, as you can see the differences, only the solution is not visible. But comparing it to another, or the two, colloid and suspension, it is visible. Why? Because, as I've said, in solution, once water is actually solution water is actually not visible. Kasi nga, isang substance or only one substance lang ang meron in a water. So the another substance that being combined in the water is being dissolved. While in the colloid, there are the phase, or there are dispersed phase called suspended particles, and there is called continuous phase, which is medium suspension. Meaning to say, even though the two substances is being mixed or combined, even though the other substances is dissolved, nagkakaroon siya ng cold changes in the color of the mixtures. Like for example, if the powder milk, if you mix it to a water, eventually the powder will be dissolved, but the changes is in the color itself. So kung i-compare natin siya with the water, there is no color with the water, but comparing it, if may milk na siya, of course the changes of a color is there. Comparing also into the suspension in the light source, throughout the light source. Why? Because in the suspension, bakit siya visible? Because of the particles or the substance, the other substance is not being dissolved. So meaning to say, the flour in the water is not being dissolved. That's why it serves as that's why the light source or the light passes through it. Kasi in the suspension, the other substances does not dissolve. While in the colloid naman, there is so-called another substance that being suspended, or that being that eventually you can see it throughout the changing of color, while the solution completely dissolves siya. That is why in solution, it is not visible. Colloid, it is visible. And for suspension, it is visible. So, meaning to say, the light can pass through to colloid and... the light can be visible through colloid and suspension, but not visible through the solution. So that was the process called Tindel Effect. So next we have suspension. Suspension, these are the mixtures, as I've said, with the particles that are larger than 100 nanometer. After it is well mixed, the phase of suspension look homogeneous, but they will eventually settle. Most oral medicines are suspension. So as I've said a while ago, that suspension is the mixture in which solute particles do not dissolve but get suspended throughout the bulk of the solvent. So meaning to say, if you mix the substance in the suspension, the other substance do not dissolve, pero magsisettle lang siya in the lower part of the substance of the mixtures itself. Hindi lang siya madidissolve. You can eventually, like for example in sugar and water, makikita mo yung nas-dissolve talagang sugar. Pero in suspension, hindi. Like for example nga yung if you mix flour and water, hindi siya nadidissolve ang flour, right? Pero nakikita mo yung particles na bumababa or nagsisettle down sa pinaka-bottom ng container ng mixtures. Kaya that is suspension. So one of the suspension is actually an example or a division of heterogeneous. When we say heterogeneous mixture, it is the mixtures that even if when you mix it well, the resulting mixtures of two or more substances is not uniform. So meaning to say, even though you mix the two mixtures, makikita mo pa rin yung substance ng yung other, yung substance, yung properties ng substance na isa at saka yung property na gi-combine mo. So what are those in food? You can eventually know that the mixtures is hetero in a salad, like for example a fruit salad. When you mix the different sizes or the different type of fruits in one, hindi mo pa rin maka-classify mo pa rin sila by its name of the fruit, by its size, kasi nga yung substance hindi uniform. So that's why if you mix the two substance that is not uniform, eventually you can see the original, or makikita mo pa rin yung hinalo mo na substance. Okay? So, what else? What are those example pa ahead aside from the food? Like, for example, if you mix a fruits. Another example is oil and water. As you can see, oil and water cannot be combined, right? When you combine it, hindi siya eventually ma-mix. Even though you mix, you stir it, hindi. Umaapaw pa rin si oil. So, that is an example of heterogeneous. Hindi pa rin nami-mix. As you can see, ma-define or ma-classify mo pa rin ang two liquids or ang two substance na gi-combine mo. Kung i-compare mo to homogeneous, like for example, in the salt and water, hindi mo na makikita or hindi mo na makikita yung properties ni salt kasi it's being dissolved na. So that's why the mixtures, that's why the substance that you've been combined in homogeneous mixtures form as one. Pero dito sa hetero, makikita mo pa rin ang two substance na i-combine mo. Like for example, nga sinabi ko oil and water. What else? We also have sun and water. Sun cannot be dissolved in the water also. We also have kerosene and water also. Yan, hindi mo pa rin makikita mo, or that kind of substances cannot be mixed, but it can be combined. It can be combined but cannot be mixed. Meaning to say, hindi mo siya ma-mix ng isa para mag-produce ng isang figure lang. Makikita mo pa rin yung dalawang gi-combine mo. So that is heterogeneous mixtures. So now let's proceed to the ways, methods of separating mixtures. The separation of mixtures into their components may be done using physical processes. What are those? We have first filtration. Filtration is a process that requires a filtering medium that traps the insoluble substances while allowing the liquid containing the soluble substances to pass through. So there are two division for filtration. We also have residue and filtrate. Residue is the solid components that remain on the filter paper after filtration. Filtrate is the clear liquid collected from the filtration. So filtration is a process in which you are actually filtering a certain substances or a certain mixtures. So one of the example on how can you get, or how can you do or make filtration in a process in mixing or in separating sand and water. So by separating sand and water, we'll be needing, of course, filter paper for the filtrate, or the para ma-collect yung for the residue. For you to collect the solid component, you have to use filter paper, and we also have to use funnel. Okay, we also have to use beaker or Erlenmeyer flask for the filtration processes. So by that, yung naiwan sa filter paper mo, that is called residue. Meaning to say, you were now separating the solid part of the mixtures. While yung filtrate, yun yung liquid na nasala mo or na filter mo from the mixture. So yun yung sasaluhin ni beaker at ni Erlenmeyer flask. So that is the process called filtration. Next to filtration, we also have sedimentation. Sedimentation is a technique involves heavy suspended particles that are allowed to settle. So meaning to say, in sedimentation, these are those particles that being actually mold in the in the bottom of the container, or either in the land. Like for example, to be specific na lang, like for example, a soil settling in a pan of water. So di ba sa water, if you will mix water and soil, titigas si soil doon sa bottom ng container mo, or titigas si soil doon sa baba ng land, or magiging lupa siya from the water itself. So that is sedimentation, meaning the particles that being suspended, tumigas sa baba o sa bottom ng iyong container, or either in the land. In the river itself, of course, yung mga tuyong dahon, like for example, those particles that being mixed in the river, lahat ng yan nagsasubside sa baba. At yung nagsasubsub sa baba, yan lahat ang tinatawag nating sedimentation. Meaning to say, tumitigas siya sa baba, so probably it can be a sand na namimix na siya sa sand or sa stone sa baba ng river. So that is the process called sedimentation. All particles that being suspended, heavy suspended below or in the bottom of the surface. So that is sedimentation. Next is decantation. It is a process of separating liquid from the solid component of mixture, pouring out the liquid carefully without sediment being disturbed so that it remains at the bottom. So what are the example? Best example of it is when you transfer the liquid to another container without disturbing the particles. So how can you transfer it in another container in a fastest way? So that is a decantation. So literally, like for example, if this is your container, then this is the container that you have, container 1, and this is the container 2. So decantation process is along the way on how you transfer, like this, how you transfer the liquid to another container without disturbing the bottom or disturbing the suspended particles in the bottom of the container. So that is decantation. Okay? Next to decantation, we also have simple distillation. For simple distillation, it is a method used to recover water from aqueous salt solution. So what are the example of simple distillation? Okay, one of the example of simple distillation is actually mineral. Yung mineral na iniinom natin, that is simple. That mineral that we drink is actually undergoing the process called simple distillation. Meaning to say, the procedure by which two liquids with different boiling points can be separated. So that is simple distillation. Next to that, we have chromatography. Chromatography is a technique used to separate and identify the components of a mixture. So what is the best example for chromatography? So the best example for chromatography is actually it can be used as an analytical tool. So it's very higher with regards to the technology of chromatography. There are a lot of examples. We have paper chromatography, gas chromatography, ion exchange chromatography. Those example of it is particular or can be used as an analytical tool. So we'll be discussing furthermore with the chromatography if you already now in the analytical chemistry. Kasi chromatography has been, I will be explaining it furthermore in that time because it is one of analytical tool that we will be using in analytical chemistry. Okay? So next we have evaporation. Evaporation is the process of separating a soluble solid to a liquid or solvent. So it's very understandable. Actually, the separating ways, methods on how to separate mixtures, the evaporation method is very easy. Why? Because it's actually you are actually separating the soluble solid to a liquid or a solvent. So what are those examples of evaporation? Number 1 is actually boiling water. So as you undergo with the process of boiling water, you are now having evaporation. So that is very simple. Kasi lagi naman tayong nagbo-boil ng water. We already done that in many times, even though in our houses, we've already done that. So that is the example of evaporation. Lastly, we have sublimation. Sublimation is the process of directly turning solid into gas. So what are the example for sublimation? Best way to explain the sublimation, of course, in the process on melting an ice. So if in melting an ice, sublimation or the process that is being shown in the process melting an ice is sublimation. Why? Because the solid itself is turning into a gas from its solid, which is an ice, then eventually will melt it and will turn it into a gas. So one of the, aside from melting an ice, dry ice or solid carbon dioxide is one of the process of sublimation. So other than melting of an ice, we also have dry ice. So as you can see in the illustration below, these are the examples of those, or these are the process on how we conduct or we make a certain separation. So, ito sila lahat. Let me zoom it. Okay, yan. Okay, so thus the picture will show you the different types of separation mixtures. So by the picture below, we have this first picture. It is the process of distillation. Second one, filtration. Third, sublimation. Fourth, we have evaporation, as you can see. Third, we have chromatography, and lastly, we have sedimentation. So that pictures will show or illustrate you on how we can actually make or done a certain process of separation of mixtures. So now let's proceed to the another topic for this day. We also have elements and compound. So aside from substance and mixtures, another way to separate physically matter, we also have elements and compounds. So now let's discuss what is element. So element is a substance that cannot be separated into simpler substances by any chemical means. To date, there are 109 elements have been identified, discovered, and or artificially made, and 83 of them occur naturally on Earth. For convenience, chemists use symbols ranging from 1 to 3 letters to represent the elements. The first letter of the symbol is always capitalized, but the second and third letters are not. So basically, when we say element, these are composed of atoms that actually have the same atomic number. So again, when we say element, it is composed of atoms that have the same atomic number. So that is element. So the examples of element is actually in this in the illustration below, in the periodic table of elements. These are the 109 elements that being found in the periodic table. So these are the example of elements. Okay, I'll be discussing that one later on. So next part, we have compound. For compound, it is a substance composed of atoms of 2 or more elements chemically united in fixed proportion. Unlike mixtures, the atoms in the compounds can be separated only by the chemical means. So meaning to say, in a compound, it is a combination by 2 elements. So when a 2 elements being combined, it is called compound. But unlike in the mixtures, the 2 substances can be separated by the means of chemical means. So these are actually resulting, or compound is actually resulting from the union of the separate elements. So literally, it's very simple when we say compounds. It is the combination of 2 elements. Once the 2 elements being combined, it is called compound. So what are those examples of compound? We have water. Water is a combination of hydrogen and 2 oxygen. So it leads with water, H2O. We also have carbon dioxide. Carbon dioxide is a combination of a carbon and a 2 oxygen again. We also have sodium bicarbonate, or the baking soda. It is a combination of sodium. So for sodium bicarbonate or baking soda, it is a combination of sodium, hydrogen, and carbon, and of course oxygen, or it is actually called as carbonate, combination of carbon and 3 oxygen. So that is a compound. So let's proceed to a quick tour of periodic table. So allow me to read this one. It's actually in history. So this is the background of periodic table. In 1869, Russian chemist, namely Dmitry Mendeleev, started the development of periodic table, arranging chemical elements by atomic mass. He predicted the discovery of other elements and left spaces open in his periodic table for them. The position of element in the periodic table tells a lot about the element. The shaded or area of the periodic table comprises the metalloids element, whose properties fall between those of metals and non-metals. To the right, the shaded area are the non-metals, including hydrogen. So I will not be reading it all, or not be reading it all, kasi you will I know you can read it na. So, eventually, let's go now to the illustration. So, kaya nga sinabi, the shaded area that is in the middle is actually fall in the metalloids, which is separating the metals and non-metals. And to the right shade area here, this part, this is the non-metals. Okay, non-metals including the hydrogen. Okay, well, including the hydrogen, which is located in the topmost of it. So from this area, from the right area also, it is the location of alkali, or which located topmost of the alkali metals. To the left area, okay, sabi ko nga, to the left in this area, this is the location of metals. So I will be giving you the characteristics of metals and metalloids. I will not be reading it furthermore na kasi I know you can read naman. So let's go now, or let's proceed to the three categories of elements. So I will be giving you the description of and the definition of it. We have the summarization of metals, non-metals, and metalloids. So metals are defined as an element that are good conductors of heat and electricity and have the tendency to form positive and ionic compounds. So why it is called as a good conductivity of electricity? Because of the presence of the elements called copper. So there are elements that presented or has a presence of good conductor of electricity. That's why metals is called it's called as a good conductor of electricity. And next we also have non-metals. Non-metals is actually elements that are usually poor conductors of heat and electricity, and it has more varied physical properties than metals. Elements that belong to this group include nitrogen, oxygen, and the halogens, noble gases. So eventually non-metals is actually a non-good conductor of electricity kasi lahat ng elements na nasa non-metals are the noble gases. So eventually noble gases cannot produce a electricity. Okay, so next to that we also have metalloids. Metalloids are the elements with properties that fall between those of metals and non-metals. So these are the elements more likely share their valence electrons, forming covalent bonds. So these are metalloids. So upon discussing in this in this description and how they chemically bonding, let's go on to the how can we identify the properties of each of metal, non-metals, and metals and non-metals only. Okay, for metals, always remember that metals are lustrous in nature. What do you mean by lustrous? I've already discussed that one in the physical property, right? Lustrous, when we say luster, metals are shiny. So aside from that, metals are also malleable. When we say malleable, what do you mean by that? I've already discussed. It is a property of an element that can be hammered, that is malleable. Metals are ductile. Okay, when we say ductile, so if malleable can this is the property of an element that can be hammered. Ductility is actually a property of a certain element that can form into thin sheets. So I've already discussed that in my previous discussion. So metal are a good conductor of heat and electricity kasi nga because of the presence of different element that can produce electricity. One of those is the copper. So aside from that, metals are good conductors of heat. Okay, another, again, ulit lang. Metals are solid at room temperature. So, and metals have high density. So that was the properties of metals. Next, we also have non-metals. As I've said, non-metals are elements that lack or do not have characteristics of metals. Meaning to say, one of the characteristics of metals is being a good conductor. So that is the lacking points of non-metals. So if metals are lustrous or shiny, non-metals have a dull appearance. Kasi nga, those elements that presented in non-metals are noble gases. So as you can see, if you picture out the description of noble gases, it is not shiny, right? So that is why non-metals have a dull appearance. Next, we also have non-metals are brittle. When we say brittle, it is actually the process that has a easy to break down. So that is one of the characteristics of nonmetals. Next, we have nonmetals are poor conductors of heat and electricity. Kaya nga, it is very contrast to metals. Why metals is a good conductor of electricity. Next, we also have nonmetal exists in three states of matter. We have solid, liquid, and gas at room temperature. Kasi nga sinasabi ko, nonmetals elements that belong in nonmetals are those noble gases. Hydrogen is presented to nonmetals, right? It is in the topmost of the alkali metals. Okay. So for the last one, nonmetals have a low density. Bakit? Bakit kaya? So meaning to say, when we say it is low density, walang bigat, or there is no cold mass of it, kasi it's a double gases, walang bigat, walang density. Yun ang non-metals. Comparing to metals, it is very high in density kasi may specific mass, may specific bigat siya. Okay. So that would be the properties of non-metals and metals. If you have questions and clarification, you can leave that in our GC. So thank you very much for today, for listening to me, and I hope you understand our discussion. So with that, have a nice day and God bless everyone.